Well, hello Internet, and welcome to my Rust video tutorial. In this one tutorial, you're basically going to get a 500-page book crammed all into one video. In the description is a link to all the code along with a cheat sheet, all on GitHub. And basically, the reason we're going to use Rust and why Rust is important is it provides a high performance that is similar to C++, and is a systems programming language that is excellent at reducing memory-related errors. And by systems programming, what I'm referring to are low-level details like hardware and memory. On top of that, garbage collection is not necessary. Memory errors, as we know, often lead to security breaches, which makes Rust very attractive. Rust programs also tend to require much less memory in comparison to other languages. And on top of that, Rust also excels when it comes to concurrent programming. At compile time, many possible concurrent programming problems are pointed out, and the Rust compiler is so robust that it normally finds errors not found by other language compilers. And on top of that, these error messages are normally very easy to understand. Now, if you want the installation, that's at the end of the video. Otherwise, I'm going to jump directly into writing some code. Now, I'm going to be doing this on Windows, but all of the commands are exactly the same on every operating system. So what you're going to do is you're going to go to the directory where you want to create your Rust project, and you're just simply going to come in and type in cargo new, and I'm going to call this Rust tutorial, right, like that. And basically, Cargo is the Rust package manager and build system, and you can use it to download libraries and build them and do countless other different things, which we will cover as we continue. So just type that in, and there it's created. And you can see here is our Rust tutorial. So I'm just going to change over into my Rust tutorial directory, and we can investigate what exactly is going on inside of here. Now, basically, whenever we run this command, we're going to generate a Git repository, a source directory, and a TOML file, which stands for Tom's Obvious Minimal Language for people that care. And it is basically a cargo configuration file. I'll show it to you here in a second. Here we have Visual Studio Code, and you can see our Rust tutorial here. I'm going to go into source, and also explaining a little bit about what is going on here. Here you can see the TOML file that I referred to earlier. And it's basically just a configuration file. And it contains information on configuring the package along with dependencies, which we'll get into later on. Cargo.lock, which is right here, is going to store the versions for all of your dependencies. And anytime you would ever want to update all of your dependencies, you can just go into the command line and type in cargo update. And there's a bunch of other different cargo commands that I'll get into later. But let's just jump into main RS. And you can see here is our Hello World program. Now, the very first thing I'm going to do is, this is only for the tutorial. I normally do not do this. But in this circumstance, if I want to get rid of warnings that talk about unused variables, I can just come in here and go $, and exclamation mark, and then allow unused. And that will get rid of some errors whenever I have variables that are declared but aren't being used. So that's the only reason I'm putting that in there. Now, there are a ton of different libraries that we're going to be able to work with. I'm going to go and just install a couple of them here. I'm going to say that I want to use our standard input and output library. So that is just standard and IO. And I'm also going to want to, another thing, just to cover everything, if you would want to bring in all public items under this library into your specific scope, you could just come in here and put a star after that, but I'm not going to do that in this circumstance. Another thing I'm going to need is the ability to generate random values. You can just type in rand and range. Now, as you add this, you're going to notice there's an error message that pops up. And that's no big deal. What you're going to do is just go into your TOML file right here, and underneath of dependencies, you're just going to put in rand, and this is a reference to the current version number. And you're going to save that. And then what you can do is, if you ever want to find out what the version number is for, these are called crates, which are just bundles of code. You can just go to crates.io and type in whatever different crate you're looking to use, and as you can see right there, it gives you the version number. Another thing you can do with these libraries is you can come in here and you can actually use nested paths if you want to import many of them at once. So I'm going to go standard IO, and then I'm going to say that I want write. This is going to be used later in the tutorial to be able to work with files. So we're going to say we want the buffered reader, and we buffered read, and ErrorKind. I'll get into exactly what all of these are later on whenever I get into working with files. And I'm also going to say use standard, just mixing things up here just to give you a good understanding of how we can import all of these different libraries. Okay, and also I'm going to use something else called ordering, which again I'll cover later on, and this is going to be used with something called match, which I'll also be covering later on. All right, so we have everything here, and we have our main function. And if you do not see run up here, where this is actually going to allow us to run our application, it's going to go and compile everything for us. You can see hello world shows up down there. I'm also going to move this over to the right side, so move panel right, and there we go. And I think that's going to work out a little bit better for being able to see exactly what's going on. All right, and let's just go and collapse this all together. All right, so here we are, and here is the ability to run your application. Just click on run and it runs. And if you don't see that, just make sure that you have the Rust Analyzer selected over here, and it will show up under extensions. It looks like little Tetris pieces. Okay, so what exactly is going on here with main? Well, whenever we create any function, we're always going to start it off with fn, and whatever the name of the function is, followed with parentheses, and you're going to throw parameters inside of there. And then you're going to have opening and curling braces that are going to define where your function both starts and ends. It is very common to indent with 4 spaces inside of Rust. And print line is what we call a macro. And you can tell what is a macro and what isn't. If you can see the exclamation mark there, then you know it is a macro. And that is what it is. And of course, this prints out hello world onto the screen. Not that complicated. But let's make it a little bit more complicated. What I want to do here is I actually want to ask the user of our application what their name is, and then address them with their name. So I can do something like, what is your name? Like this. And then what I want to do is I want to be able to define what is called a mutable variable, and that means it's a value that can change. By default, all variables you create inside of Rust are immutable, which means you cannot change their value, but you can set them up also to have them be mutable. And how you do that is you start off every declaration of a variable with let, and if it's mute after this, that means it's going to be a value that can change, and if there's no mute, that means it can't be changed. And I'm just going to call this name, and then I'm going to call string new, and what this is a function that's going to return an empty string. And as you can see, things are populated here for me as I go and write my code. And this is just seeing that I want to go and create a string, and it's automatically throwing in string and assigning it to the name variable. So, cool stuff. And if you're wondering why exactly Rust uses immutable variables, variables whose values can't change, the reason why is by using immutable variables, that is going to basically eliminate having to go and track down how values change throughout your code, which is going to save you a ton of time when it comes to debugging. I could come in here again and I could say something like let greeting and assign, it's also going to be a string. And I could just say something like nice to meet you, and I'll show multiple different ways of working with strings as we work through here. Now, if you want to be able to receive input from the user, you're going to use readLine for that. And to use it, we're going to say IO and standard in. We're going to be reading information from the keyboard. And read line. I'm going to mark here that I'm going to be using a mutable parameter. and I'm going to say that its value is name, or its name is name. And then what we're going to do is we're going to type in expect and didn't receive input. And that might look a little bit weird, but basically the read line function is going to receive name, and the and right here, the and symbol that I have highlighted right before mute, is going to define that this variable is a reference to the variable. And this is going to allow readline to save values directly to the name. And once again, you're going to use mute anytime you're working with a mutable variable. And this part right here where it says expect and message didn't receive input, well, readline actually returns what is called a result. And a result is an enum, an enumerated type. And an enumerated type is basically a type that has a fixed number of possible values. And the two values that are going to be returned are either going to be OK, capital O, or error, like this. And all of this error handling is directly built into Rust. And what you're going to be able to do is you could go in and say if error is returned, you can go and say that the operation failed. And on top of that, error is also going to tell you why the problem or why the function or what have you actually failed on top of that. Now, we should handle this error, but we'll cover that later on also. So now what I'm going to do is I'm going to go and actually make this more interactive. I'm just going to have this be hello and with print line. And if you want to go and insert different variable values inside of print line, you just use these curly braces like this. And I could say something like exclamation mark. No, you don't need the exclamation mark. I just threw that in there just to act like I'm very, very excited to meet whoever this is. Then I'm going to type in name, and I'm going to type in trim end like this, and that's just going to get rid of the automatic new line that is going to be inserted at the end of name because the user hit a new line. And then afterwards, I'm going to say greeting is going to pop inside of there. And if we save this and we click on run, you're going to see over here that it's going to ask me for my name. I can type in Derek like that, and it's going to say, hello, Derek, exclamation mark. Nice to meet you. Okay, so good stuff. Now I want to do more of a deep dive into variables. Another specific type of variable we have is a constant, and they are almost always going to have a name that is in uppercase letters to differentiate them from any other type of variable. And another way you can go and separate big values is you can use an underscore like this, which is very useful. If you use it properly, there you go. And on top of that, well, it doesn't know what this is. If I want to define exactly what type of data type we have here, I just throw in a colon, and I'm going to say that this is going to be an unsigned integer, which is 32 bits. What else can we do? I can also, let's go and create another constant, and let's call this pi. And we can also work, I'm going to get into all the different data types, but just to give you a quick overview, this is how we define a float. And I can say something like 3.141592 or something like that. And another thing is, let's say we define a variable called age, and we define that it is actually a string. You define strings with double quotes and characters with single quotes. Very important to remember that. And what I want to do here is I'm going to create another mutable, and it is also going to be called age, but it is going to be an unsigned 32-bit integer, right like this. And what you're going to be able to do in Rust is you can define variables with the same name, but with different data types. And this is called shadowing, and it's perfectly legal to do. And so let's go in here. Let's say I want to go and convert the string into this unsigned integer. I could say age and trim, which is going to get rid of any white space. And then I can call parse on it like that. Again, I'm going to handle any errors here by saying expect. And then we can say age wasn't assigned a number. And you can see you're building in all of your error handling directly as you code, which is ridiculously awesome. I can then come in, and because this is mutable, I can change the age like this. And then we can call print line on this. And we could say something like, I'm whatever, and I want, and let's say that we want to throw in our money inside of here. So our big constant value that we have inside of there. And then I can follow this up with just age and 1 mil. And there we go. And then we can, of course, run this, and you're going to see that it goes over, and it prints all exactly what we expect, but it doesn't have the underscores inside of there. And that brings me into more specifics on data types. Now, Rust is statically typed, which means all the types must be defined. And these types are going to be auto-generated very often for you by the compiler, as you have seen. Or you can go in and define them explicitly in certain situations in which that would be useful. First off, we're going to talk about integers, and you can see here are the different unsigned integers that we have, as well as the signed integers and how you define those. And usize is going to depend on your computer. So if you have a 64-bit computer, then it is going to be 64-bit. So let's go get rid of that. One thing that's very useful is to know the maximums on all of these different guys. And if I want to get the maximum, let's just say, rather than defining a variable, I'm just going to say print line just to save time. And I am going to say max u32, which is unsigned integer, and like this. And I can go and get our max value just by going unsigned integer 32-bit and max, like that. And I can do this for all of the different data types, but I'm just going to do it for a couple. So let's copy this, paste that there. Let's do something like 64, and you just change this to 64. And let's do the usize also. So let's go copy and paste that there. And let's say this is usize and usize like that. You can also U28, well, let's show it here so that you can see it. So let's paste this down inside of there, and U128 and U128. And let's also look at our floats. So we'll do something like max and F32 and F32 over here. And also, let's just go and copy that as well. And we'll do U64, and then that's it. That's all I'm going to do. You can go in there and do as many as you'd like afterwards if you'd like. And then I'll get into the specifics of the precision on these different data types, so, because that is also very important. You know, as you can see, these are very, very large numbers, okay? And you can also see how the precision works on these values, okay? So, important stuff. All right, what do we want to do? Another variable type or data type that we are able to work with here is what are called booleans, which I'm sure you're probably well aware of. And we can just define this with boolean, and we can say something like is true is equal to true. And one thing to remember is, let's say that you have an unknown, up here I'm not showing errors when I have unused variables, but let's say you have a variable you just want to use as a placeholder and it's not currently being used, and you want the Rust compiler to ignore it. You can just start it with an underscore, and the Rust compiler won't throw any types of errors. And the possible values for bool is true, lowercase t, and false also, which I'm guessing that you probably already knew. Another one is if you wanted to create a character, you could come in and just say let and my grade. And remember, with strings, you're going to use double quotes. With characters, you're going to use single quotes. So that is going to create a character, and you can see it's automatically populated. And math is pretty simple to work with. I want to talk about the precision of the different floating point numbers. So I'm going to create I'll just call this num1, and I'm going to define that this is going to be 32-bit float is equal to, and I'm going to go and put 1 point, and I'm going to do 15 ones. All right, and then what we can do is I can call print line, and I'm going to type F32 like this, and then throw our value inside of there like that. And of course, you're going to want to put quotes around all of this stuff. So I accidentally put 2 curly brackets, not good. Let's get rid of those. And instead, let's throw quotes inside of there. And then after this, I'm going to go and actually add those values together. So I'm going to say num1 plus, and then I'm going to go and get 15 digits again so that we can see how precise this is. So I'm just going to change this to 0 point, and then I'm going to go and put 15 digits in there after that. And there we are, and there we are. And let's just go and do the same for 64-bit so that we can see all of it at the same time on the screen. So I'll throw that like this and change this to num2 and change this to 64 and leave that all the same and change this to 64 like that and change this to num2. And if we run it, you're going to see the accuracy we have here. A 32-bit float is going to have 6 digits of precision, while a 64-bit is going to have 14 digits of precision. Let's go and create some more. Let's look at a couple more math operators. Of course, there's a bazillion of them. I'm just going to cover some of the basic things that you're going to use all the time. So let's say we have a number 5, and we have another one, and this is going to have a value of 4. So let's just throw 4 inside of there. And I'll show you the basic math operators right at this moment. We're going to, let's say we wanted to say something like 5 plus 4 is equal to, and they're like this. And then we can just go and make this calculation directly inside of print line. So we say num3 plus num4. And we can, of course, do this with all of the basic types of operators that you would use in mathematics. So I'll throw in minus. Everything's the same. There we go. And then for this last one, this is actually going to give us the remainder. So I'll throw a remainder inside of there. And if we run it, you're going to see all the different math operators and exactly how they're going to work. Another thing to be aware of is if this was mutable, so let's change it to mutable. If we wanted to be able to add 1 to this value, we could just come in here and just say num3, and instead of saying equal to num3 plus 1, we could say plus equal to 1, like that, and we would be able to do this with all the different operators. Of course, you would just replace that addition sign. Another thing it's interesting to do is to generate random values. So let's get rid of all this. And I'm going to say let random num equal to rand. And you're going to call thread range. And then you're going to call generate range. And you're going to say that you want all values between 1 and 100. And this is how you designate a range. You have 1 dot dot, and if you want 100, you're going to have to put 101 because it goes up to 101, but it doesn't include it with our results. And then we can come in and simply type something like random, and we can get this value. So we'll say random number, and of course, if we run it, it's just going to generate a random value. There, it gave me 69. If I run it again, it's going to give me 20. All right, so good stuff. So it's a couple little math operators, and now I want to talk about if expressions. A couple different ways to handle conditionals inside of Rust. I'm going to say, let's say we want to have something called age, and what I want to do here is I want to decide if a birthday is important or not. So I'm going to say that anybody under the age of 18 is going to have an important birthday, 21, 50, and then anyone over the age of 65. We're going to say those are all important birthdays, and then anything else we're going to say isn't important. Sorry if you're not having an important birthday. So all you can do is you just say if, and age is greater than or equal to. And you can use multiple different conditionals with and, like that. So I'm going to say and age is less than or equal to 18. Again, curly brackets going to define all the code that executes if these conditionals are true. So I'm going to say print line, and then I'm going to say, hey, you have an important birthday. And there we go. And then if you want to continue with this, we can do an additional conditional. We can say else if, and we're going to say age is equal to 21. And you could also do a situation where if either of these are true with the or conditional or the or logical operator, say age equal to 50. All right, those are other birthdays that are important, so we're going to come in here and copy this and paste it inside of there. And what else did we say? Well, we said if the age is over 65 or equal to, so we're going to say age is greater than or equal to 65. Well, guess what? You also have an important birthday. And then the default, of course, is going to be else. And in this situation, your birthday is not important. So we're going to say not an important birthday. And if we run that, you're going to see the age is 8, and it's going to say, yes, 8 is an important birthday. Another thing, this is sort of a kind of a ternary operator. I'm going to cover it just because I'm trying to cover everything. So if you wanted to simulate what it's like to have a ternary operator, we could say something like let and mutable and my age is equal to 47. I could do something like let can vote equal to if my age is greater than or equal to 18. And then inside of here, I could return true. And another thing is you do not need the semicolon after this if this is just simply going to return a value. So that's useful. If there was multiple different statements, only the last statement could exclude the semicolon. And otherwise, this is going to return false. And then what you do is at the bottom here, you just throw a semicolon in. And then we can come in and we can say print line. And we can say can vote. And then we could decide if we can vote or not. And you can throw this directly inside of your print statement as well, as long as you put the right name inside of there. And there we are. And if we run it, you're going to see that yes, indeed, it is true that this person can vote because they are the age of 47. Another conditional that is extremely important and useful is called match. And basically match is going to run different code depending upon conditions. Like if you're going to use match in other situations though for sort of error handling and such. And so let's go and create one. So I'm going to say let age 2 be equal to 8. And what I want to do is I'm basically going to copy the important birthday thing, but I'm going to use match instead. So I'm going to say match age 2. And then inside of here, I can also throw all sorts of conditionals. So I'm going to say, let's say that I want a range from 1 to 18, including 18. I just go and create a range like that. And if I want to also include 18, I put equals 18. You're going to follow that up with this little arrow here. And then, did I save the, yeah, look at that, I saved it. And the only thing is you're going to put a comma at the end here instead. So that's going to match everything between the age of 1 and 18. And I can do the or statement as well. So I can say 21 or 50. Again, there we are. Just make sure you get rid of that semicolon and replace it with a comma. I could also go and get 65. But you might say to yourself, well, what's the max number? Well, you could throw something like 200 inside of there or something that nobody would ever reach. But remember, we talked about this earlier, if you wanted to get the maximum, this would actually be an unsigned int, but whatever, same difference. You can go and throw that inside of there. And then that's going to get everything greater than 65. And then by default, you can do an underscore. Whoops, I accidentally hit the wrong key. An underscore is going to match everything else. And it's very important when you're using match, you have to be able to use every single possible value for age whenever you're defining all of these different conditionals. Again, helps you avoid errors. And here we can say not an important birthday. And again, leave a comma there at the end, and then a semicolon at the end of this match statement. And if we run it, you're going to see that the age of 8 is an important birthday. All right. Another thing, I'm going to cover more with match because there's a lot going on here. So let's go get rid of that. And I'm going to say that I want to define my age as equal to 18. And see, it's giving me errors. Good stuff. So I'm going to say let my age. And I'm going to say that I want it to be equal to, like that, automatically populates the data type. And I'm going to say let voting age be equal to 18. Now what I can do is go and get match, and I'm going to say my age, and I'm going to use the compare function here. There's all kinds of functions built into match, and let's say that I want to get a reference to the voting age. I can do that and throw this right here. And it's giving me an error because I haven't filled in all the different parts that are needed. And this is where ordering comes from. See, whenever I imported that library, this is where I'm using it. So I'm going to say ordering, and I can say, whoops, I think I hit it twice, or maybe not. Okay, so I'm going to say ordering and less than, that's what that's going to be equal to. In that circumstance, I'm going to say, let's throw this here, and then let's just change this to can't vote. So can't vote. And remember, commas, not semicolons. And then we can, this is basically exactly the same, so I might as well just copy it, throw this inside of there. I'm going to say greater than, so greater, like that. And it's comparing my age to the voting age that I defined here. And here, in this circumstance, I can vote, so change that to can vote. And in the situation in which these are going to be equal, like that, I can say, give like a special message here, say something like, you gained the right to vote because they're 18 or whatever. All right, and then end this with a semicolon like that and run it. And you can see you gained the right to vote because I had this set for 18. All right, so there's a little bit with match. We're going to be covering more later on, but now I want to talk about arrays. Now what's important, an array just contains multiple different values, and elements, this is very important, elements in an array must be of the same type, data type. And on top of that, arrays have fixed size. So let's go and create an array. And I'll just call this array1 is equal to, and how you define them is you just put the square brackets, and 1, 2, 3, and 4 look like great numbers, so I'll do that. Let's say that you want to print the very first value inside of an array. We can do that. So let's call this something like first, and then we can go and refer to our array that we created. So array1, and the first index is always going to be 0. If you wanted to get the actual length of your array, let's just copy this because I'm lazy. Let's go and type in length. So length like this. And to get this, you just say array and get rid of this part right here and replace it with the length function. And let's say we would want to go in and loop through these different variables. Let's create another array. So I'm going to say, actually, let's go and just run this. So let's just go run, and you can see first is 1 and length is equal to 4. Let's go and create another array in this circumstance. So you can see if I update this, so I can go and put like a whole bunch more numbers. So I can say 5, 6, 7, 8, and 9 inside of there. Boom. See, it automatically updated it from 4 to 9. So that was useful. And just to differentiate this, let's call this array2. And I'll get rid of this also. So if you want to loop through an array, what we can do is you're going to have an index. There's multiple different ways to loop. I'm going to show you all of them. I'm going to start off with sort of a weird one. So this is a loop index. It's going to change from 0 all the way up through the end of the indexes. So I'm going to say that I want this to be mutable because I need to change the value. There's no way I can do that otherwise. And it's going to start at the very first index. And we're going to say loop. And what I want to do here is I want to loop through all of these different values. And I want to only print the odd values inside of it. So I'm going to say loop. And I'm going to have to use if for this. I'm going to say if array2, and I'm going to get my loop index value, and I'm going to say, I'm going to get the remainder for this. Modulus 2 is equal to 0. Well, in that circumstance, we know that we're dealing with an even value. And so what I want to do is I want to go and get the next value after that. So I'm going to say that I want to increment this value like that. And then I want to jump back to the beginning of our loop. And that is what continue does. Continues in countless numbers of programming languages, so you're probably well aware of it. Another condition is I'm going to say array2. And let's say that for some reason we don't want to continue past 9 or something like that. So we'll throw this inside of here. Even though it's in the array, we just want to ignore it. So we're going to say equal to 9. Well, in that circumstance, what I'm going to do is I'm going to break out of the loop altogether. What that's going to do is it's going to start executing code down here. So no more looping, we're done. Break the loop, we're out. Okay, so after we do this, in the circumstance in which we want to print out our odd values, I'm just going to say val like this. And then I'm going to go and get that value. So I'm going to say array2 and loop index and print it out. And of course, don't forget to increment your index value. Otherwise, you'll have problems, clearly. And if we run it, you're going to see that it's going to go and print 1, 3, 5, and 7. It didn't print 9 because we broke out of the loop whenever that happened. All right, so there you go. That's some stuff you can do looping-wise with arrays. You can also use for loops. So I'm just going to get rid of this guy right here and delete it. And I am going to loop index is equal to 0. Let's just leave it the way that it is there. And I'm going to say while loop index is less than, and I'm going to get my array number 2. Loop index, and there we go. So I'm gonna did I forget to put that there? Or actually no, it's going to be array2 dot length. Confused for a second. All right, so there's the length. We're gonna cycle through as long as there are values to cycle through, and I'm gonna say print line, and then we can say array. And we can print the values out just like we did before. And of course, we could throw a conditional in here that would break out whenever we hit 9 if we would want to do that. I'll leave it up to you to play around with those different ideas. So array2 and loop index and that. And then, of course, we're going to have to increment the loop index. Gratefully, I saved that. And we can run it. And you can see we're also able to cycle through values that way. Of course, it doesn't end because we also have the ability to use for loops. So for val in array number 2. And in this circumstance, we need to create an iterator that is just simply going to provide us with the ability to cycle through all of those different items or iterate through them, however you'd like to say that. And we could say print line and just go and output these values as well. And it's going to give us the same thing that we had with our while loop. And I leave it to you to decide when you should use while loops and when you should use for loops and when you should use other looping structures. And there you go. We printed that out as well. And now we move on to tuples. Now, tuples can contain multiple data types in a list of a fixed size. And so let's go and create one. So I'm just going to call this my tuple. And you need to define what data types you're going to store inside of it. Let's just say unsigned 8-bit. and string and a 64-bit float. And then we can come in and assign some values. So we'll say 47, and we're going to do more about strings like right after this. But let's go in, and I'm going to convert this to a string with toString. So I'm going to say toString like that. And then finally, I'm going to say 50,000. And there we are, and there we go. Okay, so that's how we can create a tuple. And as the tutorial continues, I'll do a lot more little side projects with tuples as we get into sort of doing little mini type of examples. But let's say we want to come in here and get our name from our tuple. We can just go and say my tuple and just reference the index just like we did previously. And also you can assign values to multiple different tuples at the same time. So let's say we wanted to go and get these and put them into separate variables. So v2 and v3 is equal to my tuple. And then once again, we could go and print out one of these by referencing the index value. So just go like this, and then maybe we want to get age this time, and we can go and just call v1. All right, and if we run it, of course, it is going to output my name here and my age. All right, and I just mentioned strings, so why don't we talk about strings? Now, basically, there are two types of strings. You're going to have a string, which is going to be a vector of bytes that can be changed. And then you are going to have this reference and string type, which is going to point to the string and allow for viewing of said string. So let's come in here and create an empty growable string. So I'm going to call this mutable. st1 is equal to, and we call string, and we use a couple different functions here when creating strings. And let's go and say we want to insert a character at the, in this situation, it is at the beginning of the string, but actually pushes a character to the end of the string. So you can just go st1 like this and push, and remember characters are going to be single quotes. So we'll throw that on there. And let's say we want to insert a string at the end again. So just to prove that this push is putting strings at the end. So we'll say push str like this. And here, double quotes. And we'll just say something like word or something. And we'll continue. Let's say we want to iterate through the words by splitting at any white space that we have. So we can say something like for word, and you don't need to declare this variable word outside of here. You can just go and type this in. So I'm going to say st1 dot and split and white space like this. And there we go. And then I can come in and output these. So I'll say print line, and we'll just go and output each individual word. And there we can do that. What else would I like to do? Let's say you'd like to replace a string. So I'm going to create a new string. I'll go st2 is equal to st1 dot replace. And I'm going to say that I want to replace the instance of a with the word another. Exactly like that. And we could go and print this out. So I'll just copy this just to prove that it indeed worked. So we'll just change this to st2, right like that. And let's run this. And you're going to see that we printed a word, and then we replaced a with the word another. Let's go and get rid of this and do some more stuff. All right, what do I want to do now? Well, let's say I want to create a string of just random different characters. So we call this st3 is equal to and string. And here's another way you can create a string and at the same time assign a value to it. You say from like this. And then I'm just going to throw like a whole bunch of random characters inside of here. So X, R, T, B, whoops, B, H, double K, because I'm going to show you how to eliminate duplicates. AMC. Okay, so there we are. Just created a string. Now, if we would want to convert this to a vector, we're going to cover vectors soon, but just for now, it's kind of the chicken or the egg sort of thing where I'm trying to figure out what to cover. And I'm going to have these be a vector that is just full of a whole bunch of characters. So I can say characters and then go collect and whoops, and make sure we close that off. We're then going to be able to sort these characters. So vector sort of covering strings and vectors here at the same time. So that's going to sort them. We can also come in and let's say we want to remove any duplicates that we have. And then we can cycle through this vector. So I'll do character in v1 and then just print line. And I can go and output each of those individual characters as we cycle through this. And there we are. Let's do some more stuff before we run it. Let's say we want to create a string literal. Go let st4, and we're going to say and str equal to, and we'll just have this be random string. And let's say we want to convert to a heap allocated string. We could say let and mute. I'll get more into heaps as we continue also later on. And we'll do string is equal to st4.toString. So that's how we can convert back and forth between the different types of strings. And let's call print line again. Print line. And let's output this. And I'll just come in here like that and go st5. Anything else I'd like to do? Let's say I'd like to convert a string into an array of bytes. You can do that as well. Just call this byte array1 equal to st5. And then you call as bytes. Clearly we use strings a lot, so I'm covering a lot more with them. We could also get a slice of a string. So let's go and let's say this is st6 is equal to, and you have the and sign here, st5. And let's say we want to get everything from index 0 through 5. We would go 0, ... 6. We do not include the 6 whenever we grab this piece. And let's do a couple more. Let's say we want to print line, and I want to get this string length. I don't think I covered this. If I did, whatever, I'll try it again. And length, like that. And let's go and grab it. So we'll do st6 and length. Actually, I think I did do this. Whatever. There shouldn't be much duplicate. And then finally, if we want to delete values in a string, if mutable, we're going to say st5 dot clear. We'll do that. And anything else I'd like to do? Let's just run this, and you can see all this output. So there are all our different strings. You can also see the duplication's gone. It's also been stored, and you can see the string length and so forth and so on. What else would I like to do? So we did clear. Let's say we want to combine strings. So I'm going to say st6 is equal to, and I'm going to populate this with text. So I'm going to call this just sum, and then we're going to create another string. So let's just copy that and paste it down inside of here. So we'll go st7, and we'll say words. And what else do we want to do here? Spell words right. And what else? Okay, well, let's combine them. So we'll say let, and we'll create st8 equal to st6 plus, and we'll go and this is going to get a reference to that string with the string 7, but not with string 6. And what this means is the string 6 is no longer available. So if we try to go and call it, it doesn't exist. It is in string 8 now. However, string 7 still does exist because we use the and sign here to get a reference to it to get those values. Let's say we want to cycle through the letters in a string and print them out as Unicode. go character in, and like I said, inside the for loop, you don't need to declare anything. All that is handled for you. So we can say bytes, and let's just do another print line, and output this. Whoops, quotes, and there we are. And we'll just output our individual character. And there we go. And we can run this guy right here. And you can see there are Unicode characters and so forth and so on. All right. So rundown of strings, like I said, as the tutorial continues, we will do more with strings once we get into more complicated topics. But I think that's a good overview of a lot of what you can do. I'd like to also talk now about casting. Now, you're going to be able to convert to different types in a whole bunch of different ways. As we've already sort of touched on, I talked about strings and vectors just a second ago. Casting is going to be one of those things that is sort of covered as the tutorials continue on. And of course, you can get the code, and it's on GitHub for free. So grab it and use it as a cheat sheet, and it should be really useful. Okay, so there we go. I got that. Now, let's say we want to cast. One other additional way we can cast is through the as keyword. So we could say something like let int 3, and we'll make this underscore 32. Yeah, these are weird variable names. I'm sort of the difference between doing this for a tutorial versus, code you would use in real life. So I'm going to say int u8 as, and if we want this to be a 32-bit, we just do that, and there we are. And then we're going to do the same thing for the other part, and you'll be able to add those values together as you cast them. So this is int2 u8, like that, and there you go. An additional way to cast those different guys. All right, so there's casting with as. Another thing I'd like to talk about is enums, or enumerated types. And basically, they just allow you to create custom data types that have a limited number of potential values. So let's say we wanted to go and have our days of the week inside of here. So we could say, all right, so there you go. There's our enumerated type for all the different days of the week. Something that's interesting about this is you can actually define functions for these enumerated types. Just go like this and reference the enumerated type you want to work with, and then just throw a bunch of functions in there. So one function I could use is something like if we wanted to check if a specific day is a weekend, we can reference this type itself by passing self inside of it. And then what do we return? You're going to get more about this when we talk about functions. Whenever we create a function, it starts with fn, then you have the function name, then you have all the parameters passed to it. Then after this little arrow sign here, you're going to have the return type. And the return type is Boolean. And we'll talk about those very, very soon. And we're going to use our old friend match here again. And you're going to notice in Rust that you use match a lot more than you would use ifs and statements like that, else's and all that. So we're going to say if day is Saturday, or if the day is Sunday, well, in that situation, we are going to return true as a statement. And then, remember, we have to always cover every potential value or situation whenever we're using match. And this guy covers everything else. So we'll just say, if it's anything that's not Saturday or Sunday, well then return false. All right? So let's then come in and actually use these guys. So we'll go and we'll actually use an enum, and let's call this today, and reference day, the enum name, and then we reference the enum name again, but in this circumstance we pick a specific value. So let's say today is Monday. Now we can perform also different actions based on those days. So we could say something like match and today, and we'll just throw in all the different potential days that we have. So we have Monday, and if it's Monday, what are we going to do? We're going to go and print out something clever, like everyone hates Monday. All right, that's not very nice, is it? Okay, what else can we do? Well, we can go in here and do this for all the different days, and why not? And there you go. I went and put those in there for every single one of the days, and they're, well, I don't know, they're just things to say to print. And what we can do now is check if a day is a specific weekend or something like that. And you can play around with this code, and I think it is a spectacular idea to do so. So we'll say, is today the weekend? And this is going to give us either true or false using our function we used. And how we do that is just call today, and then we can call our function directly from inside of it. So we'll say is weekend, like that, and finish that off. And what are we doing here? Oh, I labeled this as days instead of day. So just change that. That's going to get rid of all the errors, I believe. And let's run it. And you're going to see if Monday is, see, everyone hates Monday. Is today the weekend? And that comes back as false. So there you go. Those are enumerated types. And yes, we're going to do more with enumerated types later on in the video. But now I want to talk about vectors. All right. So basically, vectors are like arrays in that they can grow if mutable. And one thing is they can only store values of the same type. Very important to remember that. So let's say we wanted to create an empty vector. How would we do that? Well, we can go vector, and we need to define exactly what type of data we're going to store inside of it. So let's say I want to have signed integers. I can do this. And I'm going to call vector and new, right like that. And let's say we want to create a vector and define values. And I want to be able to grow this, so I'm going to mark this as mutable. And we just go vec like this, and then 1 and 2 and 3 and 4. And there we go. What else would I like? Let's say we want to add a value to the end of our vector. We can go vector 2 and push and throw 5 on there. Let's say we want to get the value from a specific index. We could say, like, let's say we want to get it from our first vector, this, and then go and reference our vector 2 and 0, like that. We can also go and verify values exist. Very important. Very good idea to do so. So I'm going to say second and I32 equal to and vector 2, 1, like this. And I'm going to say match vector 2 dot get 1. And with this, what we're going to be able to say is if we have a value here, then in that situation, well, we know we can get the second value. All right, so important. And if you don't like errors, so we'll say second and like that and second. And again, whoops, that is a comma. There we go. And then if we get none as a response, we can handle that and just simply come in and say no second value. Okay, so no second value. What else can we do? Whoops, comma again. What am I doing? All right, comma. All right, so also we can cycle, and we can also change values because this is marked as mutable. So let's say we want to cycle through and we want to multiply every value in our vector times 2. So I can say for I in and mutable vector 2, and this gets a reference, of course, and we can go star I if we want to be able to manipulate these values equal to 2, and then we can cycle through said vector again. So we'll say and vector 2, and we'll just print this out to verify that we actually got what we expected. So we'll throw this here and up there and I. And what else? Well, we'd like to be able to get the length of a vector. So we'll say print line and vector length vector length, and we'll throw that there. And then to get our vector length, you're going to notice that the variable names are the same for collections and for in many situations. If you do the same type of thing, Rust was intelligently put together so that it uses the same types of names. And let's say we want to remove the last value. We can also go pop like this. And in this circumstance, we are going to just call for that specific value that we popped off. And I'll say vector2 dot pop like that, and like that, and like that, and all of that code. And let's run it. And you can see that we got all of our information that we were expecting. So pretty cool stuff. Alright, so now it's time to talk about functions. Now you can actually define your functions before or after main, but in this circumstance I'm going to define them before. And you just start them off with fn. We've done a little bit with functions. And I'm going to cover the most important concepts with functions now, and then later on in the tutorial I'll cover generics and generics with functions whenever that makes more sense. So we can just come in here and do something like hello, like that, and it's just going to execute exactly what the code is inside of our function whenever we run this. All right, and it's going to say hello. There you are. That's it. All right, so let's make something a little bit more complicated. Let's say that we would like to be able to pass arguments to a function. So we're going to say function, and I'm going to call this getSum, like that. And then I'm going to say x. Now we're going to have to define exactly what this is. I'm going to say that I want this to be a signed integer, 32 bits. And I'm going to do the same for the next. So like that. And then curly brackets. And then we can come in and do something like print line and do something a little bit more complicated. Not much. And equal to, and then get those values that were passed to us like this. And then at the same time, directly inside of here, go and make said calculation. And we can come in and change this to get sum. And then inside of here, say 5 and 4, or something like that. And run it. And you're going to see that it was able to make that calculation. Okay. So let's get a little bit more complicated. Let's say we want to return a value. So let's call this getSum2. And everything else here is the same. What we're going to need to do, however, is since we are returning a value, we need to say the data type for the value that we are indeed returning. And here, what we're going to do is we are just going to type in x plus y. And this is going to be the expression that's returned. And if you use the semicolon, you'd actually get an error because a statement doesn't evaluate to a function. So you're just going to leave it exactly like this. And we can just come in and say print. And then after that, you can just put the value inside of here. We don't need to do anything fancy. So just do this and like that. And get rid of this extra guy and throw a quote inside of there and get some 2 like this and 5 and 4. And don't forget the parentheses there at the end and run it. And you're going to get an answer of 9 because we passed in 5 and 4. All right. You can also use return if you'd like to do that. So let's just for consistency reasons, we'll just leave this like this. And we could say return, and this would return our value for us as well. So get some 3 and run it. And you can see that it also gives us 9. You're also going to be able to return multiple different values. So maybe we just want to call this get2. And it's just going to get passed 1 value, and it is going to return 2 values. Well, how do you do that? Well, you're going to have to define the data type for the 2 values that you return, and that's it, basically. All right, and then we're just going to say return, and let's say that we want to return 1 plus the value passed and 2 plus the value passed. Just go x plus 1 and x plus 2, and then we'll just come in, and how are we going to use this? Maybe down inside of here, we can just come in and get rid of this. And remember how we received 2 values? Well, we just put them inside of parentheses. And we'll call this value 1. And we'll call this value 2. And this is going to be equal to, and call get 2 like that. And pass 3 inside of it. And then we could go and print out these different statements. So maybe we just say nums and get both of those values and print them to the screen. And this will just be value 1, of course, and value 2. And there we are, and run it. And you can see that we got both of our values. All right, so that's how we get multiple values passed. Maybe down inside of here also, we would like to be able to define a number list and pass a list to a function and then have that list of values be summed. So I'm just going to call this number list, even though it's a vector, but that's fine. And vector, like that. And then we'll throw in 1, 2, 3, 4, and 5. And then we're going to call our function right here. And actually, if you want to pass a function, what we can do, we'll just call this sum list. But just so I don't get derailed here, let's say we have some list here and we want to pass a vector to it. How we do that is we're going to say, this is going to cause an error, but that's okay. We're going to say sum of list is equal to, and our function, whenever we create it, it's going to return one value, and we can call sum list, which is what we're going to be passing, and then and number list, and you pass a reference to the location for our number list. But how do we receive it up inside of here? Well, up inside here, let's just get rid of some of this stuff. What we're going to be doing is returning one single value. So let's just get rid of that. And this is going to be I32 like that. And inside of here, to be able to receive our list, we're going to call this list. And then we're just going to say and reference, and it's going to be a vector that is going to be a reference to a vector. All right. And we want to sum all these different values inside of here. Let's get rid of this also. And we're going to say let, and we're going to have a mutable, and I'll call this sum equal to 0. And then I'm going to cycle through how we cycle through these list items. Covered this already, but it's good, of course, to cover it again. List, and we need an iterator that is going to be able to cycle through all these different values for us. And then we can just say sum plus equal to, and then to get the actual value, we put our reference operator inside of there. And then to return a value, we put sum again, and we do not put a semicolon unless we put return on that, but we didn't. So there we are. And you can see sum of list is equal to 15. And there is a rundown of a little bit on functions. Much more is coming. So let's just get rid of this here. And what we want to do now is talk about generics. Now, basically, or specifically generic types, we can actually specify the data type to be used at a later time with generics. And it's mainly used when we want to create functions that can work with multiple different types of data. And it can be used with structs, enums, traits, etc. We'll cover traits later on. And so let's go and create some. So up inside of here, remember you can put your functions before or after main, doesn't matter. But one thing we're going to have to do here is we are going to try to add two values that we do not understand. So let's come in and first let's just try to do this, and then errors are going to come up, and then I'm going to show you how to solve them. So I'm going to put gen on there for generic. And what we're going to do, like if we just put t inside of here like this is normally how you define a generic. And then you say that you're going to receive two values like this and y like this. And then you're going to return some other value, data type, that we don't know what it is. And then we're just going to go return x plus y. We are not going to be able to do this. Why are we not going to be able to do it? Well, you cannot use this addition operator here on generics in the form that we are working with. So what we're going to do is we're going to talk more about traits later on. But basically what this is called an add trait. And what it does is it specifies the functionality of the addition operator for different data types. So we need to go use standard OPS and then add like this. And this is going to allow us to perform addition with our generics. But we're going to have to change some stuff. So we can't just simply say T. And what we do is this doesn't have to be T. It can be T, U, whatever you want it to be. It's just a stand-in, and the compiler is going to understand this is a generic type, meaning that it's literally any type, and we are going to want the compiler to work through it. Now, there's some limitations, but basically this add trait that we have right here is going to allow us to work with different types of numbers, a wide range of different types of numbers. And I leave it to you to go and actually search for this. You can just type this in, type Rust, and paste it inside of there, and it'll show you all the different data types that it will allow you to add with if you type that in and so forth. All right, you can see the problem goes away now. So now what we want to do is just go and add these values together. So down inside of main, we can go and say print line, and we can say 5 plus 4 is equal to, and then we can call our get sum gen function, and we can type in 5, and we can type in 4, like that. All right, so that allows us to work with integers, but it's also going to allow us to work with floats, and like I said, multiple other different data types that you can look up. So let's say this is 5.2 and 4.6, and the name stays the same, obviously, and we can change this to 5.2 and this to 4.6 and save it. And even though the data types are completely different, it's able to work with both of those different data types. All right, so a little bit more on generics later on, but that is the basics of working with generics. And this brings us to the concept of ownership. Now, memory is going to be managed through a system of ownership with rules that are checked at compile time. And to understand this, you must understand the difference between two parts of memory, which would be stack and the heap. Now, you have the stack, which is going to store values in a last in, first out format. And with the stack, data on the stack must have a defined size. Then you're going to have what is called the heap. Now, whenever you're putting data on the heap, you request a certain amount of space. And the operating system then is going to find space that is available, and then it's going to return an address for that space. And that reference to the space in memory is going to be called a pointer. It's like an address. Now, there's a couple rules that you have to be aware of. Each value is going to have a variable that's called its owner. There's only one owner at any one time, and whenever the owner goes out of scope, the value is going to disappear. So basically, whenever the compiler says, okay, we're no longer going to be using this, then it just is deleted and that memory is free. Now, one thing to be aware of is while automatic deallocation of resource is great, there are problems that can occur. So imagine, for example, if you copied a string. If you do, the string just stores a pointer to the first index and the memory required for each character, and then the number of characters that you would have. Now, what happens if, for example, we would delete one of those strings? Well, that information would then be deallocated for both strings. Now, this is whenever we would copy. And you just have to understand the concept that Rust is going to free resources by default in most circumstances. But what's great is the compiler's super awesome, and it's going to alert you to potential problems almost always. So that's a great thing. So for example, let's give you an example here versus just talking. So let's say we have let and string 1 is equal to and string from, and we're going to assign a word to this, being world. Then we're going to go let string 2 be equal to, whoops, messed that up, string 2 is equal to str1, like that. Now, we just copied that over. That means it doesn't exist anymore. So, for example, if you would come in here and try to print this out, so you'd say something like hello, like that, and str1, like that, you're going to see an error. What does it say? Borrow of moved value is string 1. Basically what that means is you took the value that was originally assigned here and assigned it here, and this does no longer exist. All right, so that would cause a lot of problems. However, let's say we would come in and we would instead say that string 2 is going to be cloned. So we'll just change this to string 2 is going to be str1.clone. And what this is going to do is it's actually going to make 2 copies in this circumstance. And whenever we do this, you can see the error actually goes away. And if we run it, you can actually see that it's going to print. So it's just the difference between using the assignment operator and using the clone operator and understanding both of those. Another thing that's important to understand is that this is not going to apply with data types such as integers, booleans, characters, floats, tuples. It will apply with strings and arrays and vectors and all that stuff. Let's create some functions here also to sort of demonstrate what is going on. So I'm going to come up here and I'm going to create a couple functions. Let's go function and just print string. It's going to receive a string like this, and it is just simply going to print that string. So we'll say print string, and we will say a string, something like that. And let's go and get the value passed inside of there and print it. Let's do a couple of functions though, so that we can sort of see. Now we're going to go print and return. Whoops, return string. And again, it's going to receive a string, and it's going to return a string, and like this. And why don't we go and print the string and then return it? So we'll go like this, copy, paste that in there, and then also return the string. Remember, we can just put X inside of here, and that's good. And then on top of that, let's also come in and try to change the string. So we'll say change string, and we'll go name. And to do so, we need to say it's mutable and that it's a reference to our string. And inside of there, and we'll say something like name, and just to use a function for this, we'll go push string, like this. And we will say is happy. So like that. There we go. And what else? Let's go and print line, and we'll print out a message here. So we'll say message, and the message is going to be whatever name is. So there you go. Couple different functions that we have here. Now let's run them. So we can just go, what do I want to do with this? Let's just leave this the way that it is. And let's get rid of this print statement right here. And I'm going to say print string. So it's just pretty straightforward. Print string. And which one do we want to print? Let's try printing the first string. So you can see here's print string. It just receives the string, and it's going to say a string and print it. All right, pretty straightforward. And you can see that it prints a string world. All right. So a little bit weird, but there you go. And what else can we do? Well, let's test out the returning of a string. So I'm just going to leave this like that. And then I'm going to come in and I'm going to say let string 3 equal to print and return string. And we'll pass in string 4 again, or string 1 again. And if we run that, you can see that it's going to go and print that out on the screen as well. All right, so good stuff. And it's going to be stored inside of here. So if we go and take this and we print this out, whoops, like this, we can go and get string 3 is equal to and str3 semicolon. So it's going to print out that statement, and it's also going to return the value from our function. And then if a function is going to borrow a reference, it can't change it unless we create a mutable version of it. So just remember that. And another thing that's important to remember is you can only create one mutable version inside of a function. So just a couple little things that we can do here. So let's change this to my name. Let's get rid of this because we never use it anyway, and it's just getting in the way. So we just wanted to call for that string to be changed. So we'll go change string and mark this as a reference and mutable and string 1 like that. Oh, and of course we're going to have to make this as mutable. That's why it's giving me that error. Errors go away and run it. And you can see that it didn't print. It did indeed print Derek is happy. All right. So rundown of working with strings and passing those to functions, and more on those subjects in the future. But of course, I have to move on. And what I'd like to talk about next are hash maps. All right, so hash maps are going to be used to store key value pairs. And to use them, we're going to need to come in here and get a library. So we're going to say use standard collections and hash map like this. All right, so now that we have that set up, we can come inside of main and create some. And remember, all the code is available in the description. It's on GitHub. So let's say we wanted to do something like some superhero stuff, and we'll say hash map, and to create a new hash map, we just say new. And then what we're going to do is we can insert different values into our hash map. So we can say heroes dot insert, and what should automatically populate. So we're going to say Superman, and we are going to say Clark Kent, like that. And boom, and it automatically knows these are strings. See, that's how great the compiler is for Rust. It saves you a ton of time. So let's go and create a couple more, and you can see there's the K and the V for key and value. Paste this inside of here. And what we're going to do next is let's do Batman or something. So Batman, and he is Bruce Wayne. And this, so Bruce Wayne. And for the last one, we will do the Flash. And so the Flash. And we will go Barry Allen. Okay, so there are our hash maps and our hash map values. Now you can iterate over a hash map and get our keys and values. So we can just go K and V in heroes, and we need our iterator to be able to iterate through them. And then we're just going to go and print out both of those. So we'll say this is equal to this, and then we can just go K and V. So it just gets the key and the value all at the same time. So we run it, and you can see that it does do that for us. All right, so let's say now that we want to get our length for our hash map. How do we do that? Well, we just go length and take a wild guess, because Rust is very consistent with its naming. It's just heroes like that and length like that. Now, very often we want to be very safe about what we are doing with Rust. And so let's say we want to check for a specific key in a hash map before we try to print out anything or something along those lines. Well, we could say if heroes dot contains a key, and it's going to be Batman. So we'll say Batman, whoops, Batman spelled correctly. Well, in that circumstance, we're going to say let the Batman, and get rid of this space, let the Batman equal to heroes dot get and Batman. Whoops, like that. Now we can use match to verify that the Batman exists. So we can say the Batman, and we could say sum, and X is, whoops, why did I do that? Let's just get rid of this altogether. Sum X, and then in that circumstance, what we want to do is we want to print out Batman is a hero. So print line like that, and Batman is a hero. And otherwise, if anything else comes back, we want to say none, and we will say print line, and we'll say Batman is not a hero. And change these to commas. and boom, and boom. And there you go. And we can run it, and you can see that Batman is a hero. Comes back. All right? So cool stuff. Rundown of HashMaps and some things that you can do with HashMaps. And now I want to talk about structs. Now, a struct is a custom data type that's going to store multiple different types of data. So we can create a struct here, and let's call it customer, and define the types of things we want to be able to store about our customers. So we say something like string and address, which is also a string, and balance, maybe the amount of money that said customer owes us or something like that. Okay? So let's go and actually create a customer. So we'll say let, and we want it to be mutable. So we're going to mark it mute is Bob. And then to define this, you just say customer. And then you're going to say the name is going to be string from, and we'll say his name is Bob Smith or something like that. So there's that. Whoops. And there we go. And then we'll say his address is going to be string from, and it is 555 Main Street. And then we'll say that Bob Smith owes us $234.50. Okay? And then put the semicolon at the end, and there you are. You just created a customer. Now, what would you do if you wanted to change a value? Well, we could just go, and this is mutable. That's why we can do this. We could say string, and we could say what happens if Bob Smith moves. So we'll say that Bob Smith moves to 505 Main Street, and then that's it. There we are. And we could print this out, and you'll see Bob's new address. Now, what is interesting is you can actually accept multiple different types of data using generics, just like we did with functions. So let's go and let's create, let's just delete that, and let's create a struct, and it is a rectangle, and we'll mark it as T and U, and boom, like that. And we'll say that we have it's going to store length, which is going to be a certain T value, and height, which is going to be a certain U value. We can then come down inside of here and say let rec equal to rectangle, and then assign said values to this with x4 and y 10.5, something along those lines. Except this is going to be length, and this is going to be height, like this. There we go. So that's how we would define that. Another thing that we can do is we can actually tie struct properties to functions using traits. Remember I kept talking about traits all the time? Well, here's our opportunity to use a trait. So let's create a trait called shape. And what's cool about this is these functions can be used by any structs that implement the correct trait. So we're going to go trait shape, and we're going to define a function inside of it. So this is what we would refer to as a constructor, and it's going to return a certain shape. And so we'll just call this length, and we'll define that it is a float, and that it has a width, which is also a float, and it is going to return itself. So there we are, and that's why it's called a constructor. We can also come in here and define some functions. This is an area function that is going to belong to this trait, and it is going to receive something that is a shape type of trait, and it is going to return a float. Okay? So what this is doing is just defining what everything, it's sort of like an interface in object-oriented languages. It's defining the things that anyone who implements our shape must do. So let's go and create another rectangle here. So struct and rectangle, get rid of all that, and let's put this after this. So let's go cut this out of here and move that there. Now we can come down here and go struct rectangle, and length colon F32 and width colon F F32. And let's do something similar also for circle. So we'll do this and like that, and then just change this to circle. And all that we'll just leave the same. And then what we can do is implement the trait for rectangle. So we'll go implement shape for rectangle like this. And we're going to have a constructor here. So we'll say new and length, and this is F32, and width is F32, and it is going to return a rectangle. And then we can come down here and say return rectangle with a length, and spell length right, and width. Likewise, it's giving me an error because I didn't go and also create array, or area, I mean. So now we're going to say area. Self is going to, of course, allow us to refer to parameters that for this specific struct. So we're going to pass self into it. And this is going to return a float, just as defined. And in this circumstance, we'll say return self and length times, so the rectangle's length and the rectangle's width. And you can see that that all gets passed back, but this needs to be capitalized exactly like that. Now we can implement the trait again for circle, and we're basically going to do exactly the same thing. So let's just copy this, paste this inside of here, and implement shape for, but in this circumstance it's going to be circle instead of rectangle, and a couple things need to change. This needs to, of course, be circle, so it's going to return circles, and this is going to be circle also, so there's circle and length and width. And then down here inside of area, of course, this isn't quite going to work. What we're going to need to do is change this to a circle area, and so we'll divide by 2.0 like that, and then just get rid of this, that, and go the power function for floats, so 2.0, and then we are going to multiply that times our pi value that we created earlier. So this is a constant. Let's go up here and put it inside of this guy right here. So we'll go constant pi F32 is equal to 3.141592, like that. And there is our pi value. And now what's cool is we can actually refer to these as if they are shapes. So we created both of those, and we can go let, and let's just call this rectangle is equal to shape and new, and we'll say that this is just 10 and 10, just to keep this very, very simple, like that. And we'll do the same for our circle. So we'll change this to circle, of course, and change this to circ or something. So there's circ, and shape new, and everything else is exactly the same. And now what we can do is we can come in and create our area for this. So we'll get rectangle area, and that is going to be this. And we will say rectangle area like that. And that is going to give our rectangle area. And then we'll do exactly the same thing for our circle area. So circ area, and just change this to circ like that. Da 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 da. And we can go and run it, and boom, you can see we get our correct answers. All right, so cool stuff. There's some messing around with, and also you're going to be able to use generics and such. Go ahead on your own and play around with throwing in generics just like we did before. That would be fantastic fantastic practice. And up next, what I want to do is talk about packages, crates, and modules. All right, so of course it's very important to keep all of your code organized. And of course, what I'm doing here where I have, a main function full of stuff is not normally how you program. Now, you can split your code into multiple files, And packages can actually contain multiple crates, which is just files with code in it. And you can define what code is public as well as what code is private. Now, what I want to do here is I actually want to go and create a new folder inside of the source directory. So I'm going to go up inside of here and click on that. And I'm going to use what is considered to be a common way of introducing new people to these type of modules and crates and so forth. I'm going to use a restaurant example. And basically, it's going to break the code across multiple different files and allow you to just simulate working in a restaurant. Now, what's important to know is that crates are modules that produce a library or an executable. Modules are going to organize and handle privacy. Packages build, test, and share crates. And paths provide a way for us for naming items such as structs and functions. But I'm going to, inside of our restaurant folder we just created here, I'm going to create a new file. And this file also will be available on GitHub. And I am going to name this mod.rs. There that is. And here is our module that we're going to create. Now, something that's important to know is packages can contain 0 or 1 library crates, and they can also create as many binary crates as you would want. And if you want to create binary crates, what you would do is create a bin folder and save those. But I'm not really going to get into that. I'm going to sort of keep this as understandable as humanly possible. So this is where we're going to create our module, and it can contain other modules, and it can hold functions, structs, enums, constants, traits, and I'm going to show you how to reference those. And it just provides a way for us to organize our code, and also it allows us to make certain parts of our code private as well as public, and everything is going to be private by default. So we are going to create a module, and I am calling this pizza order, and I'm going to create a struct inside of it, and it is going to be called pizza. And our pizzas are going to, we have to make this public. So what is a pizza? Well, it is dough, which we're going to say is a string, and it is also cheese most of the time, and it is also going to have a certain topping. So we'll go topping, and we'll just say that these are some sort of default things, and these are all going to be strings. Okay, so we created a struct. What do we want to do now? Well, we want to implement functionality for this pizza struct. So we'll go implement pizza, and that just means we're creating functions to interact with it. So I'm going to make this also public function, and let's say that we're going to focus here on just a lunch scenario. Of course, you can have multiple different scenarios, and I'll get more into that. So we're going to have a topping, and string be passed to this, and it is going to then return a pizza. So we will create our pizza inside of here. And we need to define different things, and we're going to do some default stuff. So we're going to say our dough, and we're going to mark this as a string from, and we'll just say regular dough. And let's move this over a little bit so that we can fit everything here all on one line. So regular dough, and then we're going to say our cheese, if I can spell cheese. There we are, cheese, again, string, and from, and we'll say mozzarella, and then we are going to say that the topping is going to be user defined. So of course we could have all these be user defined, but I'm just trying to keep this as simple as humanly possible. And that is going to be whatever topping they passed in, and get rid of, put that like that, and that is going to create our pizza. All right. So what are some other things that we'd like to do inside of this guy? Well, we would like to be able to help the customer, and then we're simulating a restaurant experience here, okay? So we're going to say that this is going to be public, and we're going to make it public so that our other functions can call it. And we're going to just call this help customer, And all this is going to do for us is it's just going to have a function inside of it. We can throw a whole bunch of functions inside of it, and we'll say seat at table. And whenever this is called, this is just simply going to say print line and customer seated at table. Table. There we are. Okay, so fairly simple. And what else are we going to do with this? Well, we're going to throw a couple other different functions inside of here. Maybe we want to be able to take the customer's order. So we'll say public and, oops, yeah, let's make this public. And we'll say fn and take order and throw that there. And what this is going to do is it's going to be a little bit more complicated. This is going to call the seat at table function for us, and it's going to seat the customer. It's very important to understand that making help customer public doesn't make this child function also public. So we have to make both of them public if we want to be able to make them accessible. So now what we're going to do is say customer pizza, and we want to call super on this. So pizza equal, and super is going to allow me to access pizza in the parent scope. So we'll do like this, so we can go to the next line and say super pizza, and we are specifically looking for lunch that we are going to pass a topping of veggies to. So there's that. And then after we do that, we're going to call serve customer and custom pizza. There we are. Okay, so simulating this whole experience by breaking everything down into functions. All right, so we have serve customer here, but we didn't create that function, so let's create that. So we'll say serve, and this doesn't have to be public. So anytime something doesn't have to be public, of course, we don't want it to be. So we're going to say pizza and super and pizza. And then down inside of here, we can say print line and the customer is served a regular pizza with, and then our specific topping. And to get that, you just say customer pizza like that and topping like that. Whoops, I accidentally hit my caps lock. Topping. And there we go. Now, we have all this set up, but we want to be able to provide a public function that is going to allow other files to come in here and sort of use these functions. So to do that, I'm going to go public function order food like this, and then it is going to reference the other code we want to work with here. To do so, you go create, because these are both in our source directory. So, and we're going to be calling this from our main function. So we go create, which is that source directory. Then we have to say what directory we want to access. We want to access restaurant, which we created. And then we're going to say pizza order is what we want to, whoops, pizza order, like that. And then specifically help customer, like that. And then we want to access take order. And this is how we are able to work our way through all these different parts. So restaurant's the directory, pizza order. So we're coming up here to our module called pizza order. Then we're going to help customer. So we're going to go to this module inside of here called help customer. See, we have functions inside of here. We have modules inside of here. We have everything. We also have structs inside of here. And help customer, and then we go to take order, which is this specific function. So that's how we walk our way through actually accessing all of these different functions. Then over in main, we can call order food, and it's automatically going to access all of this stuff. And that is just how simple it'll be. So we say order food, and I think I saved that. And if we run this, it's going to say, hey, order food, can't find location for this. Okay, did I save that? Let's go back over here and save this. Jump back over here, save it again. And what's it saying? It's saying cannot find function order food in this scope. Well, why is that? All right, so if we want to use these over in our main function, well, we need to say, hey, we need to use these. So what we want to do is we want to declare that we want to use the restaurant module here. So you just go mod and restaurant like that. And then to finally get rid of that error, we need to declare a specific function we're going to be using, which is going to be order food to access that. So we'll say use crate and restaurant like that and order food. And there we go. And now the error goes away and we run it. And you can see that it is going to work. So we'll say customer seated at table. Customer is served regular pizza with veggies. And that is what we were looking for. So there you go. Again, play around with this and test out your own ideas to really master it. And up next, what we're going to do is talk about reading and writing to files. And at the same time, I decided to combine error handling with this so that you get a hands-on example of how error handling is useful. Now, Rust doesn't have exceptions like other languages. It's going to handle recoverable errors with result, which we've seen already, and the panic macro for unrecoverable errors, which we've also actually seen. At least I think I made at least one error. Now, basically, when the panic macro executes, your program prints an error, and memory's cleaned up, and then the program quits itself. So we can just go and trigger one on ourselves if we would like to. So here's terrible error, and we can just go and run it, and of course it's just going to print terrible error and all kinds of other information, all right? But that's normally not something we would want to do. So let's go and trigger a panic error here on our own. So let's say we want to access an array that is, like an index in an array that doesn't exist. That's a situation in which you would have an error. And I already showed you how to avoid this error previously. So let's come in and just throw in something just to cause an error. So we'll go little array, and we'll say that we want to access index 10, and then we'll run it. And you can see, yes, indeed, that's bad, and all kinds of bad stuff happens. All right? But what I wanted to do, rather than just cover that, is to show you some real-world scenarios. So I'm going to show you a whole bunch of different ways to handle errors. And in this specific situation, what we're looking to do is work with files. But this will apply to just about any other type of ways of handling errors. So what we want to do is we want to create a file. And it's just going to be called lines of text. Okay, so there is our file. And basically what happens, well, let's just go and create a file and handle the errors along the way. So we're going to say let output equal, and we'll call file create. So this is going to create our file, and there is the name that we have. Then we're going to say let mute output equal to, and here is a situation in which we're handling potential errors. We're going to say match output, and basically what is going on here is result is going to have two variants. We're either going to have OK or error. And the T is going to represent the type of the value that is going to be returned in a situation in which everything is okay. And in this situation, the E is going to represent a specific type of error. So what we're going to do is basically handle those. So we're going to say OK and file. In this situation, we're just going to use file. And otherwise, we're going to get an error. So we'll say error, and in this situation, we're going to come in, and we are going to trigger panic, which is going to put an error message on the screen, which is going to be, our specific file creation error. So problem creating file, and then we could come in here, and because this is a result, we want to go and put a colon and a question mark inside of here to catch this specific error that was triggered. And this error is triggered because we have to put curly brackets around this. So just go get the curly bracket, and then come down here and after this put our closing curly bracket. And that problem goes away, and you have to end this with a semicolon. All right? So now what we want to do is we want to write to the file and define the panic error message that could be expected if there was some type of a problem with it. And we're going to use expect for that. So we're going to say we want to write to the file, and we're going to put our output inside of here. And then after this, well, we're going to actually write down exactly what we want written to the file, and this is how we issue new lines. So we're going to just random words. So that's what we want to put inside of there. And then after this, we'll say expect, and this is going to be the error that is triggered if we could not write to the file. So failed to write to file, right like that. And there we go. All right, so let's continue. So multiple different ways of handling errors, triggering errors, and so forth. Now let's go and let's say that we want to open a file, and if everything is okay, what we want to do is we want to unwrap and return the file if there was no panic triggered. So we're going to say let input equal to and file open and path. This is our file name. And then we'll call unwrap. And that's what unwrap does. Unwrap basically ignores the result and just gives us the output that we want to receive from our file. So that's another way of going around using the result. So we're going to say buffered, and we're going to call our buffered reader to read this in one line at a time. And then we'll say input, input, there we are, get rid of that, input. And now what we can do is cycle through and print all of those individual lines. Let's just keep this all on one place. So down here, we'll just go for line in buffered dot lines, and then we'll say print line and put all of this out onto our screen. So we'll say buffered like that, and line dot unwrap. Again, unwrap is going to give us the content we want instead of giving us a result. And then we can come up here and we can run it, and you can see just some words. So we were able to write to the file, and then we were also able to receive just some words from our file. All right, so good stuff. Another thing you can do is you can also catch specific errors. So this is going to sort of stack. So once again, let's go let and output to equal to file and call create again. And this one's just going to be called random text. Then I'm going to say let output to equal to match output to, and then handle OK again. So OK file and return file. And otherwise, if we have an error, I'm going to go and look for specific errors this time instead of just a catch-all scenario like we were using before. So here we'll say match error and kind, and then look for specific times or specific types of errors. So, and you can look these up. Of course, the situation will change depending on what you're looking for. So let's say we have a not found error. Well, then we can stack match, and we'll say file, create, and we want to create our file, and that's what that's going to do for us. And then we can also stack additional errors here. So we can say, or additional matches here. So we'll say, okay, if our file is created. So we said, hey, we want to get this file. And I said, hey, we don't have that file. And he said, okay, I want to catch that file. Or I want to create that file. And then it said, okay, create it. And now we're going to catch any errors that would come about by trying to create a file. So we'll say panic. And then in this situation, we could say can't create file for some unknown reason that the error message will provide for us. And once again, instead of getting a result in this circumstance, we want to use colon and a question mark here to get our actual error printed out. And there that is. And down here, we have to put another comma. And then after that, we could go and do a catch-all for any other potential errors that we might have. So we can just say other error. And in this situation, also trigger panic. And here we'll go problem opening file. And again, to print out the error message, colon, question mark, like this, and whatever the error was in that circumstance. So you got that, and then another comma here, and a semicolon here. There he goes, and I think I got everything, and we can come in and we can run this, and you can see that that prints that out, and there were no errors in creating anything else. So there you go. There's a rundown of how to open and write to files and read from files, and also a whole bunch of different ways of handling different types of errors. And now what I want to do is, I've talked about iterators, but I want to briefly cover them a little bit more. All right, so basically an iterator can help us cycle through values in arrays or vectors or maps. We're going to cover maps here in a second. So let's go and let's create a mutable array and give it a value of 1, 2, 3, and 4. Whoops, you have to put this inside of square brackets. 1, 2, 3, and 4. There we go. And we'll create a iterator for it. So we'll go array it and iterator like that. Just allows us to cycle through those values and go and print out said values right like this. So there we go, and there we go. Now, an iterator is going to cycle through these values by borrowing. So it's not going to actually take the collection and remove it from memory. It's going to borrow those values. And so the collection is not moved. But the one downside to this is you're not going to be able to change values if you use it this specific way. You could also come in and go array it like this and into iterator like this, and in this situation you'll consume the collection, but you'll no longer be able to use the collection. So there's a positive and negative to both of them. And another thing you can do is you can actually create an iterator. So let's go iterator. It obviously has to be mutable equal to and array it dot iterator like that, and then you can just go print line, and then let's say we wanted to get our first value out of this. We could actually get as many values as we would want, but we're going to come in here like this. Again, we are going to call the iterator, and what you could actually do is manually call it each individual piece inside of your collection by just calling next like that. And that is going to allow you to get those different values. And if we run this, you're going to see it prints all of them. And then in the other situation, it's just going to print the very first one. All right. So there is just a little bit about iterators. And now I want to talk about something a little bit more cool, which is closures. Now, basically, a closure is a function without a name. And they are more than likely going to be stored in a variable. And they can be used to pass a function into another function. And the basic layout for creating a closure is you're going to say let, and you could have a variable name. Then this is the part that's a little different. You're going to use pipe characters. And inside of the pipe characters, you're going to list any parameters that you have. And then you are also going to have a return type. And then after that, inside of curly brackets, you'll have your body of, the code that actually does stuff. All right, so let's create a couple different closures. So let's create a closure that's going to define if somebody can vote. We could say something like let can vote equal to, and again, parameters inside of pipes. And you're going to say age is going to be a integer, 32-bit integer. Let's close that off. And then again, you're inside of curly brackets, you're going to do something. And we're just going to say age greater than or equal to 18. And remember, we do not need to use return in this situation. And there you go. And we could come in and then go and find out if somebody can vote. So we'll say can vote like this, and then can vote, and we'll throw a value inside of there, and it's going to give us our answer. See, it comes back as false. All right, so that's a basic type of closure. Let's get more complicated. Another thing that's important to understand is closures can access variables outside of its body, unlike functions, whenever it is borrowing. So we can go mute and sample1 is equal to 5. And then we can say let print variable equal to, and if you don't have any parameters, you just leave that empty. And you can say print line like that. And we can say, we can reach outside here and we can say sample1 is going to be equal to, and what is it equal to? Sample1. And that is going to work for us as well. And then we can just go and call print var like this. And there we go. Let's do some more things. Let's go and do sample1 is equal to 10. Change our value. And you can also change values if you mark a closure as mutable. So let's go mutable change var equal to, again, nothing in there. We'll just put that there, and we can just go samp1 plus or equal to. And what I'm doing here is I'm just showing you how these values are going to change. So we'll call change var like this and continue. So we can go print line, and we can go and output samp1's value again with samp1, and then go samp1 is equal to 10. Stuff that you can't do with a function, a normal function, unless you do other sorts of things. So, and let's just copy this rather than typing it out again. So we'll just go copy and paste this inside of here, save it and run it, and boom. And you're going to see the changing values for sample1. So sample1 is 5 right here. We jump inside of here, we print out that value, and that's the print var right there. We change it to 10, we jump inside of here, we add 1 to it, then we go and say we want to print it out again, and you get 11, and then we changed it to 10 outside of any of these closures, and it still has the value of 10. All right, so there you go. Some different proof of how you can change values using closures, mess around with those different guys. Now, another thing you can do is you can actually pass closures to functions. So what we're going to do is I'm going to go function and use function. You can also create, I don't think I've ever done this, you can actually create functions inside of your main function, something you wouldn't normally do. I'm just sort of showing you. So this is going to be a generic. And what we're going to do here is we're going to say there's 2 or 3 different variables, or 2 variables and a function. And what we're going to do is we're going to pass in one function that is going to add and another function that is going to multiply into this use function. So, and this isn't something that only works whenever you create a function in main. You can create this outside of main. I'm just doing this just for convenience reasons. Okay, so we'll go like this. And then if we want to pass in a function, we go like this. And we'll label that as a generic because we want to be able to accept multiple different types. And this is going to return a integer, 32-bit int. And then you need to say where t, and you're going to have list the style or the data types or the parameters that your functions are going to have. That's something you have to do. So we'll say I32 and I32. But other than that, the functions can do absolutely anything on those. And it's also going to return an integer. So all that is defined. And then all this function is going to do is receive this function with those 2 values, then push those 2 values onto our function, and the different functions are going to execute. When you see this work, you're going to understand. So create another closure, which is going to be called sum it's going to receive two parameters, which are going to be passed from the function use function. So I'll just label these as A and B like that. And then it is just simply going to add those values together like that. And we can come down here, grab this, and paste this inside of here. And this guy is just going to, let's call this product instead, or prod, just to be a little bit, abbreviate this a little bit. And what it's going to do is multiply those different values together. And then we can simply come in here and go print line like this and execute different ones. So we'll say something like 5 plus 4 is equal to curly brackets. And then we can go and pass different functions into that function and have them automatically execute. So we'll say 5, 4, and our closure name sum. And then we will come in here and grab this and then pass in product instead. So we'll do this and we'll do that, and this will be our prod function instead. And we can run it, and you can see that it automatically went in and used the correct function with those values that we passed in. All right, so we're going to do a little bit more with closures later on, but now what I'd like to do is talk about smart pointers. All right, so we're going to do some somewhat real-world scenarios here when we're talking about smart pointers. I'm going to talk about the box smart pointer and the reference pointer. But basically, a pointer is just an address to a location in memory. And we've been using them across this whole entire tutorial anytime we use this guy right here, which is the reference operator, to borrow a value rather than taking it and having it cleaned out of memory. And we've used other smart pointers. Strings and vectors are also smart pointers. And why is that? Well, they own the data, and they also have functions for manipulating that data. And basically, smart pointers just provide functionality beyond referencing a specific location in memory, which would be different than with other programming languages. And on top of that, as you'll see later on, they can also be used to track the ownership of data. Okay, so let's talk about box here first. And what I want to do is I'm going to create what is called a binary tree data structure utilizing box. So we're talking about box. This is a smart pointer that specifically we're going to be looking at. And basically a box smart pointer just stores data on the heap instead of the stack. I talked about the difference between the heap and the stack previously. If you do not remember, which is definitely okay, a stack is going to store values in a last in, first out format. Think of it like plates that you would stack. You would stack all your plates, and then if you needed a new plate, you wouldn't pull the plate out from the bottom and crush all the other plates. No, you just take a plate off the top. That's exactly how the stack works. And then you have your heap, and whenever you put data on the heap, you're going to request a certain amount of space, and then the operating system is going to find that amount of space somewhere in memory and allow you to store that information. Now, a box is normally going to be used when you have a large amount of data that is stored on the heap, and then you pass pointers to it on the stack. And if you want to create a box, you can just say something like let, and let's go, int1 is equal to box new and 10. Okay? And you're going to be able to access this in multiple different ways. You can access it in a very straightforward way. You could just come in and say b int1 is equal to get this value, and just say b int1 like that, and run it, and boom, there you go. You got your value back. But we're going to do something a little bit more complicated. So let's create a struct. That's what I want to do. I'm going to create a struct, and I want to try to create a binary tree. So I'm going to say struct, and I'll just call this tree node, and here is our generic. Remember I said we're going to do more with them. I'm going to have basically a tree. The way that it's structured is you're going to have, like, let's say you have a value of 50 underneath of it. If you can picture this, let's see if I can find it. So you have underneath of it, you're going to have two different arms like this, and they're going to reference other values that are underneath of it. So maybe something like 35 and 40, and then these will have additional arms, and it creates a tree. Okay, so what I want to do is try to create a binary tree data structure inside of Rust. So I have a left arm and I have a right arm where I'll store these. And this is going to store additional tree nodes inside of it. So let's do that, and then we're going to have a left and a right. So let's do this. And there's also the opportunity where we will, they won't have a left and a right, okay? So we'll have to handle that as well, which we will. And then on top of this, let's just say that each of these, keep them very simple, are going to have some type of key. All right, so there is our struct, and this is going to have errors. I know that. I'm doing that on purpose to sort of point out some different things. Now, the reason why we're going to get errors is if we try to create a binary tree, we're going to get an error, or actually multiple different errors. One's going to be that if we store like a string inside of here, that the string can't be known at compilation time. But also we're going to have other different errors here because Rust doesn't like null values. And like I said, if we have a tree and there is no additional node or value that is attached to the left or the right for our said tree, which is definitely something that's going to happen, that's going to trigger other types of errors. But I'm going to show you how you can use box to sort of fix that. So how exactly do you fix it? Well, we can just leave this largely unchanged. And the only thing that's going to be different is instead of putting tree node inside of here, we're going to say option box tree node like that. And then we'll just have everything else be basically the same. So we'll just come in here, grab this again, copy this, and paste this inside of here once again, and save it. And now you can see everything's okay. All right. So it doesn't like the idea of having a tree node inside of tree nodes and so forth and so on. And what happens if this tree node is deleted, and then we have all these other tree nodes that are tied to that tree node. It causes all kinds of memory problems. Okay, so we're going to handle that just by putting all of those additional tree nodes inside of boxes. Now what we can do is we can create some functions for creating nodes and then adding left and right nodes as well. So we'll just come in here like this, and this is going to be a generic, and we'll call this tree node, and again generic. And we can go make this public so we can access it to create new tree nodes. It's just going to be passed a key. That's the only value assigned to it. And then it's going to return a tree node. And we'll go self and create a tree node inside of here. And we just have to define what these are going to be. And it's perfectly okay in this situation to mark these as none because it's a brand new node. So we don't have anything assigned to it yet, so we'll just do none like that. And then the key part is just going to be key. So we can just get rid of all of that. Let's delete this and get rid of that and put this like this. Okay, so good stuff. And then what we can do is, well, let's throw another comma here because it's just good practice. We have that all set up and everything else looks good. What else can we do here? Well, we can go and generate a opportunity for assigning a left tree node. So we'll create another function inside of here. So left and mute, and we'll get past self and node, and we get past a new tree node after we create a new tree node with the new function. And then what it's going to return, it's going to return self. And from this point on, we will say the self left is equal to some box new node. It's getting a little bit in the weeds here now when we're messing around with this stuff. And then after we do that, we can return self. And there it is. And we can also add the option of being able to add a right node to our trees. So you can just change this to right, something like that. And tree node self, just change this to right, and provides us with the options of adding all of these other different nodes. And I forgot to capitalize box here, that's why I'm getting these weird errors. So let's get this like that, and the errors went away. And what else will we do? Well, I'm just going to, you can go and play around with this on your own. I'm in a rush here to sort of get into concurrency. But basically, to create a root node and then assign left and right nodes all at the same time, you could just go, let's just call this node 1 is equal to tree node and new 1, like that. And then we could say dot left and call on this new node that we just created. We can also go and assign, just to show you, I'm just looking for reasons to show you new stuff. So here is an additional way of creating the left node, and then let's also create our right node and tree node and also new and 3. So just an interesting way to structure that to go and create those. And you can just go ahead, play around with that. But now what I'd like to do is cover concurrency. And what I'd like to do is use sort of a real-world scenario where we simulate bank transactions. Now, basically, concurrent programming is going to involve executing different blocks of code independently. So we have what is commonly talked about, which is parallel programming. And it's different in that code executes at the same time. And these different blocks of code that execute are referred to as threads. And basically, a thread is going to handle the scheduling as well as the execution of these blocks of code. Now, there are common problems whenever you're dealing with parallel programming. For example, a thread tries to access data in the wrong order. That's a very common error. Also, threads are blocked from executing because of confusion over requirements to proceed with execution. So, for example, you have a thread that can only proceed if it has access to something, and another thread has access to that thing, and so that thread will not stop execution until it passes that information for the other thread to execute. All these other different problems. Well, Rust is going to handle a lot of these issues for us. So what we're going to need to do, is we're going to need to go in and get a couple more libraries. So standard and thread and use. I'm going to have to work with time and so forth. So I'm going to need to go and get time and duration also. And it's giving me an error. And that's because I didn't put this extra colon inside of here. All right. So there we are. So we got that set up. We got the libraries to work with. Now, again, I'm going to sort of have errors occur here, and then I'll sort of cover them. But first, let's just make it a little bit simple. Let's go and create a thread and a main thread and execute, and you'll be able to see how they trade off time. So to create a thread, we're going to use spawn. So we're going to say thread and spawn like that. And this is actually going to have a closure inside of it. So there is our closure. And I'm going to cycle through and have it share outputting information to the screen. So let's say we want to do this 25 times. And I want to say just print line, just to keep it very simple. I'm going to go and say spawned thread. There's going to be a spawn thread and there's going to be a main thread. And both of them are going to be outputting information on the screen. You're going to see how they don't necessarily always do everything in time. And now what I'm going to do is I'm going to force this thread to sleep after it prints this. So I'm going to say thread. And this is going to give our other thread the option of going in and executing. So I'm going to say from, and I'll just say 1 millisecond. So millisecond and 1, like that. And there we go. Okay, so that's going to handle that. And we have this guy right here. Now what I'm going to do is I'm going to also, outside of here, going to just inside of our main thread, this will execute. So I'll say in 1 to 20. They don't have to be the same. And we'll say, actually, I'm not making them the same on purpose, just so that I can show you something else. So I'm going to say main thread. Notice specifically that this spawn thread has 25 times it's going to print, and this only has 20 times it's going to print. Very important for what you're going to see here in a minute. So I'll say that I want to go and print that, and then I want to also put this thread to sleep for 1 second. So like this, and like that, and we'll run it. Okay, so here are our threads running. You can see there's a whole bunch of things going on. So we have our main thread is going to execute, and it prints out 1. Then you have the spawn thread main, and then you have the spawn prints twice, then the main prints two times, and then it goes down and it gets down to the spawn thread, prints out the 20. But you may say to yourself, wait a minute, this is supposed to print out 25 times, only prints out 20 times, and this does print out the, actually it prints up to 20, but doesn't include 20. So what exactly is going on here? Well, there are no guarantees on when threads will execute and if they will even complete execution in this current form. However, if we want to guarantee that they do execute, we call join. So we're going to say thread 1.join. And then what join's going to do is it's going to make sure that both of our threads are going to be able to complete. And then after this, we're going to call unwrap, which we've seen also before. And that's just going to handle the result that's passed back. But one thing we need to do is come up here to the thread part and say let thread 1 equal to thread. And that's going to handle that. Okay? And if we come in and we run it, now you're going to see that both threads are going to complete. All right, and let's just get rid of that. And there we go. Both threads were able to complete in that circumstance. But let's go and actually see what this looks like by actually using this type of a sort of a real-world example. So what I want to do is I want to sort of create a bank account and then have multiple different customers all try to withdraw money from said bank account. So I'm going to keep this very simple. This is just going to be a struct, and it's going to be called bank. And it is going to just have a balance inside of it. And there it is. It's a float. And then what we want to do is we want to be able to come in here and withdraw money from it. So like I did before, we're going to get errors and things aren't going to work right. And then I'm going to walk through exactly how to handle this. So this function here is going to be passed a reference to our bank. And so this is going to be mutable bank, and it's going to be passed an amount to withdraw. I'm going to move this over here so that we have plenty of room. So it's going to have an amount, and that amount is going to be a float. And then simply what I'm going to do is just say the bank minus equal to whatever the amount is they want to withdraw from it. And just keep that simple. And you're going to see errors are already popping up here. What's this error say? Binary assignment cannot be applied to mutable bank, cannot use on this type. Oh, that doesn't have anything to do with anything. I just forgot to type balance in there. Okay, so nope, no errors yet. Okay, so let's continue. So what I want to do now is I want to create a bank struct. So I can just go like this, and it's going to be mutable because we're going to be changing some things here. And I'm going to say bank, and I'm going to give it a default balance whenever it's created, which is going to be equal to $100. So we're going to say that we have $100 in our bank to start out with, and then we're going to start taking money out of it. And then we're going to come in and we're going to say that we want to withdraw, and we're going to pass in our bank inside of here, and we're going to withdraw $5. And then we can come in and say print line like this, and balance, and like that, and go and get our bank balance. So bank balance, and there we go. And if we run this, we're going to see that our balance comes back as 95. Okay, so everything's working so long. But one thing we want to do is we want to demonstrate concurrency here. So we want to create a bunch of customers that are going to withdraw money. So we will once again come in and we'll say function, and we'll call this customer, and it'll have a bank reference, and this is going to be mutable bank type, and run this, and then we'll call withdraw from inside of here and pass in our bank and our $5 that we want to take from it. Okay? We're starting to get some problems. And this says that we cannot capture dynamic environment in a function. This is B. This is bank, like that. Sorry. Okay, got rid of that problem. Okay, so now what we want to do is we just want to create our thread, which is going to have a customer go and withdraw money from the bank. Should be easy, right? Let's do this. So we'll say spawn, and this is going to be just a closure. And, I mean, everything looks good here, right? I mean, why shouldn't this work? So we'll say customer, and mutable, and bank. And then after this, we will go and get this guy down here. And you can actually just go join like this and unwrap. You don't have to do it the other way. Nice to show different ways of doing stuff. And then we come down here and like that. Now, the problem that we are having here with this code is that basically we're borrowing. Let me explain it another way. You can't have a situation in which a closure may outlive the current function, and especially because it is borrowing, which is owned by the current function. So in a situation in which a thread can outlive the main function and the main function has the bank, this obviously is going to cause all sorts of different problems. Now, one of the fixes for this is actually a smart pointer. And this is a smart pointer that's going to allow multiple owners, and it's also going to block access whenever these different parts are needed. And what we're specifically looking for is the smart pointer that is going to have a reference. And what we're specifically looking for is a reference smart pointer. So let's just delete all this. Let's just get rid of everything except for the bank structure here. That's still okay, and we'll be able to work with it. Now we're going to have to come in here and import a couple other different libraries. I know I'm starting to get a little bit more complicated. Just wanted to sort of end by covering smart pointers here. All right, so we'll go use and standard cell reference cell. And another thing we're going to need is an atomic reference counter, which is going to provide shared ownership of a value. So we'll use like this, and we'll get arc, and then also we'll use mutex, and mutex is going to block threads that are waiting for lock to be available. And this is in standard. Whoops, forgot to put standard inside of there. There we go. All right, so we got all this set up. Okay, so the only thing we have left is our bank structure. And let's go and simulate this whole bank transaction. So what we're going to do in this circumstance is we're going to go function, and we'll use our withdraw function just like we had before. And it's going to be receiving a bank. And now we have to say and arc. Like I said, it's going to provide shared ownership of a same value. And mutex, which is going to wait or block threads from being able to access until it's available. And then we'll throw our bank struct inside of there at the end. And this is also going to receive some amount like this. I'll put a space inside of there. Okay, so we have this set up. Now we can say let mute and get a reference to our bank by saying the bank dot lock and unwrap. And we'll be able to go in here now, and we can do some checks to make sure there's, actually money in the bank. So we can say if bank reference balance is less than $5. Remember, we're taking $5 out each time. I'm simplifying this, obviously. Print line. Then we could say something like current balance, and show the current balance, and then say withdrawal. Obviously, I'm making this extremely simple. A smaller amount. And we could go bank reference and get our balance and display that on the screen. And otherwise, if we have money in the bank, we can go bank reference balance minus equal to whatever the amount is they want to withdraw from the account. And then we can go and print some information out here. So we'll just go paste that in there, and we'll just change what this is. So we'll say something like customer withdrew and how much money they took out. And then we could list our current balance once again. And then at the end of here, we'll just go amount like this and like that, and that's good. Okay, so that's our withdrawal function and how we were able to change some different things to make this work so that we can properly borrow and lock down our information. Now we're going to be able to go function customer and the bank. And again, we're going to use this guy up here. Let's just copy the whole thing. Copy and paste this inside of here like that. And that's all that's going to be passed to this. And then we'll just call withdraw from inside of here and pass the bank and the amount to withdraw. Right, like that. And what else would we like? Well, we're going to have to create our bank. And did I save that? I hope so. Boom. I saved part of it. So let's get this out of here. And we will go, and this will be equal to, again, arc new, whoops, new, like that. New text, new bank, and pass our balance inside of here to create our bank instance. And we'll say we have $20 in the bank. We're obviously very rich. Accidentally put a reference there. Let's get rid of that. Okay, that problem solved. And now what we need to do is let's just create a whole bunch of customer threads. So I'm going to say let handles equal to, and we'll go 0. Let's create 10 of them. Then we can call map on this. And there we are. And let's run this. And what we want to do is go and create a bunch of clones of our bank. So we'll say let bank reference equal to bank clone. And then go thread spawn like we did before. And then inside of our curly brackets, we'll just call customer and pass the bank reference over and over again. And throw in that semicolon. And then what we just need to do is wait for all the customers to finish, and we can do that all at once with all these different threads that we have here by just going handles like that, and handle dot join and dot unwrap. Showed you 3 ways of doing this. Okay, and like that. And then at the very end, all of that information is going to print out, but then on top of that, we're also going to output our final balance. So we can go and go bank dot lock dot unwrap dot balance to get our final balance from our bank account. And let's get rid of that little quote there. And if we come up here and we run it all, boom, you're going to see that the customers were able to access, and you can see that the balance is dwindling down to nothing, and then eventually the balance goes down to 0, and they're no longer allowed to access or remove information or remove money from the bank. Okay, guys, so there you go. That is a rundown of countless numbers of different things with Rust. Like anything, just work through the problem, experiment, and then go on to the documentation and check it out and look for some of the different functions that I was just unable to cover just because of time limitations. But I think this will give you a big jump start when it comes to learning how to get very good at Rust. As per installing Rust, all you do is go to rust-lang.org and tools, install, whatever. Just go to rust.lang.tools and you'll be able to install just by clicking on install right here. And on Macs and Linux, all you need to do is go into your terminal, copy and paste this directly inside of there. And if you are on Windows, you're going to need the Microsoft C++ build tools, which more than likely you have. Just type in Microsoft C++ build tools to find this specific website. You're going to download those. Then what you want to do is you could go to rustup.rs. And you just click on this little executable that comes up right here. If you're on Windows, this is going to try to protect you. Say run anyway. And you're going to automatically open up your command prompt. And a whole bunch of things are going to execute. You're going to proceed with installation. And then a whole bunch of different things are going to be downloaded and installed for you. Then what you're going to want to do is go into Visual Studio. This is going to apply to Mac as well as Linux users. If you want to use Visual Studio Code, you go click on Extensions, just type in Rust, and you're going to see Rust Analyzer show up as one of the options. You're just going to click on Install. And here is Rust Analyzer. Everything has been installed. This is going to handle everything for you. Then if you want to verify that Rust has been installed, you can open up your command prompt, type in Rust C -- version. You should see something along these lines. Anytime you want to update Rust, you can just type in Rust update. And then, of course, if you want to create a new Rust project, you just type in cargo new, whatever you want to call it. You can see the directory structure that we have inside of here, just like we did previously. And of course, if you open up that code or that project inside of Visual Studio Code, you'll get your hello world, and then you can execute it just by clicking on run. So there you go. Everything I got on Rust. If you want additional information, leave it in the comments down below. And like always, please leave questions and comments down below. Otherwise, till next time.